we're going to try and recognize number patterns or number sequences, recognize what they are, and to be able to describe them using terms like the common difference, using adding and subtracting, or common ratio, which uses multiplying and dividing. And we're going to find out what a term is. So number patterns are also known as sequences because each number in the sequence will be changed in a predictable way. And each of these numbers, each number in a sequence is called a term. So, term. Strategies, there's a bunch of different ones. We only have two main strategies. The first one is looking for a common difference. Difference in the language of mathematics usually means to subtract. So it's not how two things are different. It's how what's left when I subtract the smaller number from the larger. But it could actually mean that we are increasing by a certain amount. We're increasing that difference, or we're decreasing it. So for this one, for the first one, from 2 to 6, there's a difference of 4, and we're increasing by 4. So the difference is 6 minus 2 is 4. For this one, it'll also be 4. 10 minus 6 is 4. For this one, 14 minus 10 is 4. So that's our difference, and we're going to increase it, which means plus. We can also decrease it, which means minus, but we're not going to do that right now. A common ratio, if we're looking at a ratio, we're looking to multiply or divide by the same number. So instead of adding 4, we might be multiplying, in this case, by 2. Everything's being multiplied by 2. 2 times 2 is 4. 4 times 2 is 8. 8 times 2 is 16. 16 times 2 is 32. And you could probably tell me the next one. 32 times 2 is 64. You could look for an increasing or a decreasing difference. So sometimes this one's going up by 2. But then this one goes up by 1 more than 2, which is 3. This one goes up by 4. This one goes up by 5. And we find that if we go up by 6, we can reach the next number. So the difference increases by 1 from one term to the next. And then you can look for interlinked patterns. So it can be a little bit more complicated. Patterns of odd numbers and another pattern in even numbers. So rules apply to one and the other. For example, in this sequence down here, the odd terms increase by 2. The even terms decrease by 1. And there's even very special patterns like patterns of square numbers or cube numbers. This is an example of all these numbers are 1 cubed, 2 cubed is 8, 3 cubed is 27, 4 cubed would be 64. So we get to that way. We could follow a pattern of prime numbers, or we can even follow a named pattern like the Fibonacci numbers, where you take the previous 2 and add them together. 1 plus 2 is 3. And then the next 2, 2 plus 3 are 5, and then the next 2, 3 plus 5 are 8, and then the next 2, 5 plus 8 are 13, and then so on and so forth. Really cool, right? Really cool. So find the next terms for these. So we have to find the common difference. If we're talking about difference, we are talking about adding or subtracting the difference between these numbers. So how do I get from 6 to 18? Well, the difference, 18 minus 6 is, I think it's 12, isn't it? So in this case, I'm adding 12. And if I look, I'll check it. I can use my calculator and check that I've got it right. I've got 12. So then the next number there, if I add 12 to 42, is going to give me 54. And I can use my calculator, 66, 78, or I can do it in my head. Probably pretty cool to do it in my head. Now, from here, there's going to be a decrease because I'm going down. But I'm still going to find the difference. What is the difference between 99 and 92? Well, if you couldn't do that in your head, use a calculator, but 7 is the difference. So just to check it again, this should be then going down by 7. It is. This is going down by 7. And so if I go down 7 from there, that takes me to 71. 7 more from that gives me 64. And 7 more from that gives me 57. If I wanted to do one more, 7 more from that's really easy. Now, find the next 3 terms for these, but we've got a common ratio, which is the hint that we're going to multiply or divide by the same number. So here, let's just work out. How do I get from 2 to 6? I multiply by something. I could actually find, I can sit and think, well, I know that 2 times 3 gives me 6. But I could also go the other way and go 6, divide 2 on my calculator, and it will give me that number, because these are inverse operations. They're opposites of each other. So let's see if that's going to be true. 6 times 3 is 18, right? 18 times 3 is 54. I think I'm going to start needing a calculator for this one. 54 times 3 is 162, not 462. And then I definitely need my calculator to get 486, because this is all times 3. And 3 times 486 will be 1,458. Finally, this one, you might be able to see what the pattern is. This one is going down, so it's decreasing. So the difference is I divide by 2. Again, I can have 256 divided by 128. That will give me that answer, or I can just look at it and say, you know what, maybe looking further down the line, I can see that that's half of that. You could also, you could say that it's times 1/2, which is the same thing as saying divide by 2. That's okay. 32 divided by 2 is 16. Half of 16, right? Half of 16 is 8. Half of 8 is 4, and we could continue on.